When you're ready.
Hello, my name is Monica Butz, and today I will be talking about my research on glyphosate, contamination of water sources, and neon tetra. The specific question I explored was how glyphosate affects the activity and mortality of adult neon tetra. I used three major parameters to guide and develop my research question. First, I wanted to study something related to ecology, which is the relationship between organisms and the environment. I chose this field because my interests align with the interconnectivity between the natural world and human impact. Secondly, I wanted to research something that will be relevant to future research. With glyphosate being the most used herbicide in the world, and its use trending upwards, the future world will be forced to live with the repercussions of using this chemical. And finally, I wanted to further develop knowledge on a subject that has not been studied in depth before. The long-lasting effects of glyphosate in water systems has not been available to researchers because of the relatively new use of glyphosate since the 1970s. In my preliminary research, I was able to unite all three of these parameters in finding the relation between glyphosate and neon tetras. Initially, my goal of study was to see how glyphosate affected the reproduction of neon tetras, including the number of eggs laid, mortality rate of fries, and the number of fish that survived to adulthood. Because of complications with the study, my question evolved into how glyphosate affects the activity and mortality of adult neon tetras. In a study conducted by the Southern California Coastal Water Research Project, the effects of silver nanoparticles was studied on the reproductive success of common mollies. Both silver nanoparticles and herbicides are common pollutants in water sources because of silver nanocles' efficiency in modern industry and the excessive use of herbicides. Because of their similarities, I used this study as a model for creating my own study. Results proved that higher concentrations of silver nanoparticles increased mortality rates and decreased reproductive success of the fish. The presence of nanoparticles in water sources is increasing dramatically by 63% every year because of silver's growing use as an antibacterial agent in different industries. However, leakage of silver nanoparticles can get into the environment. The use of these nanoparticles is greatly improving the health and resources available to humans, but at the cost of contaminating the environment. Similarly, the use of glyphosate is rapidly increasing for the benefit of humans and at the expense of the environment. Because glyphosate kills all plants, not just weeds, research has been conducted to create crops that are herbicide tolerant. This allows herbicides to be sprayed over large plots of land without the threat of destroying monetized crops. Farms are now able to spray higher volumes of herbicides at greater intervals throughout the year because their crops are herbicide tolerant, but the weeds are not. As this continues and more plants become resistant, the use of herbicides containing glyphosate will increase. This will inevitably lead to a greater amount of glyphosate entering water sources via runoff. Any change to aquatic life cycles can permanently alter an ecosystem. Fish populations dictate the health and longevity of a body of water. Any significant change to a certain population has effects that reach far beyond the specific species. Modern technology, paired with a growing world population, has forced the fishing industry to extract record numbers of fish from the oceans. Newfoundland, Canada used to support the largest fisheries in the world for Atlantic cod. However, after the development of radar and sonar equipment in the 1960s, the number of cod being caught each season met unsustainable levels. Canada had to enact an indefinite prohibition on cod fishing to restore the near extinct population levels. Atlantic cod were a large predator for many of the marine life off the Atlantic coast, so the populations of many of the animals they preyed on grew excessively. The decreased cod population caused a trophic cascade that made the survival of smaller predators easier. Trophic cascades typically cause a total rearrangement of the food chain, which is usually irreversible. The destruction of a population in an ecosystem forces the food chain to be restructured and can cause harmful side effects as well. Although this research did not directly address the issue of glyphosate in water, the effects of decreased populations can be an indicator of what might come with long exposure of herbicides in water. To conduct this experiment, I had two testing groups of fish. One group came from a local PetSmart and it consisted of 16 neon tetras, 8 males and 8 females. 1 male and 1 female were placed in each 9-liter tank, making a total of 8 tanks. The tanks were controlled at a temperature of 77 degrees Fahrenheit with a pH of 7.5. The tanks were all identical in setup. They all had a custom cover made to prevent bacteria from entering the water and to reduce water loss through evaporation. The covers were made with 2 small holes that allowed the water heater and air stone to be put inside the tanks. To acclimate, the fish were first placed in the tank while remaining in the bag that they were transported in. After 5 minutes, water was taken from the tank and added to the bag that was holding the fish. This process was repeated until the bag was filled with enough water to cause it to sink. At that point, the fish were released into the tank. Both the males and the females were left overnight. After an acclimation period of about 21 hours, 1 randomly selected male and 1 randomly selected female were each placed in a tank. The fish were then equally distributed between all 8 tanks. Each tank received a pinch of freeze-dried brine shrimp daily. The fish had roughly 10 hours in fluorescent light and 14 hours in darkness every day. For 2 weeks, the temperature, pH, and water levels were checked and maintained at ideal breeding conditions. The second group of fish came from a fish supplier in Florida called Imperial Tropicals, and it had 24 Neon tetra, 10 males and 14 females. This group was acclimated to the tanks in the same way Group 1 was acclimated. In this group, there were 2 control tanks. Tank 7 held 4 males, and Tank 8 held 8 females. Tanks 1 through 6 held 1 randomly selected male and 1 randomly selected female each. Because of complications with Group 1 that I will describe in analyzing my results, the rest of the study was not conducted for that group. For Group 2, the fish were monitored for 3 weeks before adding in the solutions of glyphosate. 6 total solutions of glyphosate in water were made. Each tank had 63 milliliters of a solution of different concentrations ranging from 100 parts per million to 1 part per million. Tank 1 received the least amount of glyphosate with only 63 milliliters of a 1 part per million solution. Tank 2 received 5, Tank 3 25, Tank 4 50, Tank 5 75, and Tank 6 received the most with 100 part per million solution. Tanks 7 and 8 did not have any glyphosate added to maintain 2 control groups. After the addition of the glyphosate, the neon tetra were observed for 24 hours for every day, for 3 days. No data from the fish in Group 1 was taken into consideration when analyzing the final results because of the high mortality rate of the fish. After 2 weeks, all fish had died due to unknown causes. Because of this, all data collection and analysis was based on fish in Group 2. This setback played into some of the limitations of the study. There were 3 major limitations on this study: the fish from Group 1 dying, the fish from both groups not reproducing, and the tank setup. After 3 weeks, all the fish had died. The fish from Group 1 were less active than the fish from Group 2 once acclimated to the tanks, and they were also considerably smaller than the fish from Group 2. This could indicate that the neon tetras from Group 1 were weaker and or younger than the neon tetras in Group 2. This limited the amount of data that could be collected from the first group of fish, which made my sample size smaller. The second limitation was that neither fish from Group 1 nor Group 2 reproduced. Because my original question was how glyphosate affects the reproductive success of neon tetras, my research question had to be altered to find the effects of glyphosate on adult neon tetra. And my third limitation was the tank size and setup. The tanks available to my research were only 9 liters, which is on the smaller size for preferred tank size for breeding. Another limitation with my tanks was that I had no vegetation or structures in the tanks to reduce visual obstructions in order to make observing the fish more clear. This limitation could have prohibited the fish from reproducing because females tend to like having structures to lay their eggs on. With these results, I concluded that a small amount of glyphosate in water does not affect the activity or mortality of neon tetra. This result did not align with my hypothesis that glyphosate would negatively affect the reproductive success of neon tetras. Although the fish did not reproduce, their behavior and mortality was not affected by the glyphosate. This study failed to take into account an accurate representation of how much glyphosate enters a water source and at what increments. So, if done again, the study would use more glyphosate and would be entered into the water at different increments. If this study was adjusted, multiple adjustments would be made to have more conclusive results. First, the tanks would be larger, at least 10 gallons, in order to allow schools of neon tetra to survive. Also, more active steps in promoting breeding would be implemented, such as adding vegetation, gradually increasing water temperature, and gradually increasing light exposure throughout the days. Another adaptation to the study would be to progressively add the glyphosate into the water over a period of multiple days. This would replicate the actual practice of runoff entering water sources closer than only entering the water system once. Based on the results of the study, small amounts of glyphosate will not negatively affect neon tetra. The information learned through further research would help predict, prevent, and solve the upcoming problems that increased glyphosate will bring. These are my references.
A few questions. How did your review of methods used by scholars in the field inform your selection of a method that was aligned with your research question?
I used the study conducted by the Southern California Coastal Water Research Project that explored the effects of silver nanoparticles on common mollies because their study was similar to what I was looking for neon tetras, so I based my study on what they decided and what their method was.
Okay, thank you. How do your findings provide directions for future research?
Because glyphosate is continuing to be globally used, there will be numerous water sources that will be contaminated in the future. Although my research was prohibited by the amount of glyphosate put in each tank, it can be proven that a small of glyphosate will not harm neon tetras. This provides a space for more research to be conducted surrounding large amounts of glyphosate and fish populations.
Okay, thank you. What was the most important research skill you developed as a result, and how might you apply it to your future endeavors?
The most important thing I learned was adaptation because the fish from my first group all died and the fish did not reproduce from both groups. So in the future I will be able to adapt quickly and learn how to adjust research questions to still find a conclusive result that is beneficial to the scientific community.
Okay.
Thank you.